Hello everyone, I'm Gonçalo and I'm here on behalf of Unparalleled to talk a little bit about the HumAIne platform. In the sequence of this series, you've probably already seen all of the components or most of all the components that the platform has. And so today we hope to show you how do these all fit together and what are the synergies that we can leverage from their use. So for today, I'm going to be talking a little bit about the architecture and the deployment of the platform. George will be talking about the use of Node-RED, which is a low-code environment to deploy the AI workflows, and he'll show you a demo of how different tools work together so that the developer can leverage these synergies to accomplish the goal of the platform, which is a more transparent development of AI tools. And finally, Aristodemus will be talking a little bit about the results that they've achieved on their pilot for the smart cities. So again, the goal of this platform is to help developers create AI workflows in a more transparent manner and to always be involved in the process. So we do this mostly through the use of Node-RED, which is one of the core components, again, which lowers the knowledge barrier that is needed to create them and provides an event-driven environment to keep the human in the loop. And so we also leverage synergies with other tools that maybe you've seen along this series, tools like XAI, the benchmarking suite provide insights into the AI models and the workflows, which again helps the humans involved understand what the AI is doing and how it's evolving along with the training. So for the platform architecture itself, I'm going to be showing the common frontend in just a few minutes, which is the main interface for the platform and where we can access all of the main services. So here we have Node-RED and the Kubeflow. Kubeflow is also one of the core components which serves to deploy other components like the neurosymbolic learning and the swarm learning. I believe are components that are deployed for Kubeflow. Node-RED as well can be deployed for Kubeflow and provides us a more code-intensive environment for the development of AI modules as well, something that Node-RED is not able to accomplish. All of the tools, when deployed within the platform, have a single authentication system. So one of the main advantages of having this platform package, if you will, is that all of them use the same authentication system. So once you logged into the platform or through the common front end, you can use all of the tools with a single sign-on. Finally, we have a messaging system which enables Node-RED for its event-driven flow. So Node-RED, for example, is capable of publishing messages for something which is RabbitMQ, one of the other components, and then react to events and other messages that happen within the context of its flow. Finally, MinIO serves as the main storage for whatever files may be needed, like datasets or to publish some results from a flow. And you'll be seeing HumAIne components that are not going to be listed that I have here. Some of the components are pilot site only, so maybe you've seen them in this series, but I will not be showing them or talking about it because these are pilot site, such as the augmented reality components. So, which you can find here on the pilot user and the pilot system. So these components are deployed here. So we are still working on making this available to the public, but we've currently compiled a document which has all the instructions needed to deploy different components. Something that I also want to point out is that users may not need every single component that the platform has to offer. So they don't need to deploy everything, just the things that they actually need. So it's a sort of modular approach. Aristodemus will also be talking about this case, and for their pilot, they only leveraged, I believe it was the benchmarking suite, the swarm learning assistant, and they used the active learning paradigm. So the platform does not to be used in full or deployed in full to take advantage of its components. So these are all of the components that make up the platform. As I mentioned, Node-RED, Kubeflow are some of the core components that enable the creation of the workflows. And then we have the paradigms and additional supporting components. So just going to stop the presentation here a bit. I want to give you a little bit of a tour of the common front end. So we're greeted by the main page. So here we have quick access to whatever workflows we've been working on Node-RED, and we have access to the pipelines that are deployed on Kubeflow as well. Here to our right, we have the Swarm Learning Assistant, the Swarm Assistant, sorry, and we can just ask it something. So we have our Swarm Assistant, and it can give us various insights on the platform, different paradigms about data, and we can leverage it right here. You've probably already seen the standalone version. From storage, we have access to all of the MinIO datasets and buckets. So quick access to download any files that we may want. It's thinking. Okay, yeah, so it loads all the files in the bucket. We can download these, we can delete them, we can upload new files directly from the common front end. On the HAIC dashboard, we can choose to have a dashboard of the various images that the HAIC generates. So here in settings, I can tell him to give me the images from X date to Y date. I can limit them, and I can choose the type of the images that I want. And he fetches those images from the MinIO folder and presents them here for me to display. I can download this as well as a PDF, so I can select multiple images to download them in a sort of in a PDF file. So all together, if I want to. Also loading. This is quite heavy because it's searching all of the buckets. Okay, yeah. So I can look at them. I can select multiple of them to download, and it should give me a PDF. Here I have the virtual XAI. So this gives me a benchmarking of the data set that I have. So I can choose something here just to show. It gives me all of these scores. More, I have access to the benchmarking suite as well that George is going to be showing in his live demo. And here I have the RabbitMQ, which is a messaging system, just a quick access to it. And finally, I have also the active learning. So active learning is one of the paradigms, and it's the only one that we have a quick access here to, because the others, as I mentioned, are deployed to Kubeflow. But we can do instance labeling through here, so I can do one at a time, or maybe I want to do it in batch, so I can do 10 at a time. So I can do inference as well. So the main features from the active learning API, I can do them directly from the common front end. And that's pretty much it that I wanted to show. And I'll pass the torch to George to show us a live demo using the Node-RED and the benchmarking suite.
So I'm going to take a few minutes to show you the integration layer and how the platform tools we have been hearing from Gonzalo about actually connect together in live pilot context. My part is specifically about connecting the Node-RED running on Kubeflow to real pilot data sitting in MinIO and routing it through the HAIC Benchmarking Suite to produce measurable collaboration metrics. The pilot we're using as the demonstrator is the Smart Cities parking permit system from Novaville, which you will hear about more in about moment. So the architecture of this integration is the Node-RED environment runs as a notebook on Kubeflow. This is the common front within the common front end orchestration that was described earlier, and where the integration logic lives. So the Node-RED environments run as a notebook in a Kubeflow. So this is a common front-end second level of workflow orchestration that was described earlier. Node-RED is doing the heavy lifting. It reads raw JSON logs, derives the correct field needed for trust, proxy, computation, builds the log schema, and handles the API calls. No custom code needed outside of the Node-RED, and all are wired visually. Third level is the data source, is the MinIO, where in our pilot here we have 566 real parking permit applications deposited there by the Novoville system. Each file is one complete collaboration unit, which represents citizen submits, AI screener evaluates, and municipal operator reviews. And the last step is points to the HumAIne collaboration benchmarking suite, which we're demoing live in a moment. It registers the logs, triggers the evaluation, and returns the collaboration metrics. And with that said, 566 real applications, two Node-RED flows. In one is a badge ingest, and one is a live event logging. And 5 metrics computed. So the smart cities has 2 flows. The first flow, as I said, has 10 files from MinIO, retrieved from MinIO. It's for demo. I'm using 10 for demo purposes, but the full dataset, as I said, is 500 and more. It parses its JSON automatically, derives the correct field using the 6 rule table. And it registers the session log with HAIC Benchmarking Suite. Then step B triggers the evaluation and retrieves the metrics from the configuration ID. And the second flow is the live path, where 3 HTTP endpoints, one per actor, can be used. The first one is when a citizen application created, and the second is AI screener when they are evaluated, and the third one is when the operator verified or rejected or fixed what AI proposed. And these are the expected metrics values based on our analysis of the dataset. And you will hear about the results later from Aristodemos. Going now to the live demo, I'm using the common front end. Here's the Node-RED workflow. The first step where already registered logs in the MinIO platform can be retrieved and used, parsed through this process, this workflow, and posted registered on the benchmarking suite MinIO bucket in order to be evaluated from the second workflow under the same configuration ID, so all happen seamlessly. After a step completes, as you see here, every file was parsed and the evaluation triggered. I'm showing you an earlier run because something now it's not triggered, but the concept is to have the results and in the min.io where we can see them under the min.io results under the 36 configuration ID, which is for these demo purposes, and we can see the results here and retrieved from a front end like the common front end we have here, and present the metrics in the plots like this. So with that said, these are not, of course, the real results because it's only from 10 applications and to have more. And with that said, I think I can pass the microphone to Aristodemus to explain us better the results and how they used our tools for the smart cities pilot.
Good afternoon, everyone. Many thanks, George. So I am Aristodemus Pneumatikakis, and I'm going to take it up from where George left it. So George considered a lot the how of things, so how things work under the hood. I'm going to go on to why these tools are important, what is exactly the thing they give us as pilots that have a very particular job in mind to carry out. This smart cities pilot that we are heading in Novoville, it's about a parking permit bottleneck that the municipalities usually face. We have these resident parking permits that need to be accepted annually, and the municipalities, depending on their size, receive from hundreds to thousands such applications every time. There is high procedural standardization, but profound vulnerability to errors, particularly errors that are due to fatigue, operator fatigue. We established a manual baseline and it takes roughly 20 minutes of operator time per application. And there is a risk that runs both ways. We have false negative, so legitimate applicants that are rejected, and false positives, erroneous applications that are approved. So today, the citizens submit an application via some public web form without any login being required, and the operators, council operators, log in the system and review all the applications. What we have changed is adding an AI engine in between. This AI engine evaluates all the closed sessions in a batch, comparing the form fields to some text document that supports the claims of the citizens. So at the end of the day, because we have actually arranged things in this AI engine to only take to be very certain when it accepts the applications, the council operators need only review the flag, the rejected cases, making this just a final call. We use two tools in this scenario. First of all, the benchmarking suite from Harcopian University. This provides us the quantitative structured evaluation that we need. So did the collaboration improve measurably. And on the other hand side, we use the Swarm Assistant from Innovation Act. This provides us the explanatory conversational analysis. What's actually in the data right now, and how do the data compare to past applications? We use these two tools as complements, not alternatives. Together, they cover both the rigorous evaluation needs we have and the fast internal exploration needs of the engineers at Novoville. Why is the benchmarking suite very important in this use case? We actually ended up with 3 successive AI models. But how did we end up with them? We started with one, and evaluating this one, we uncovered weaknesses, and these weaknesses led to an improvement. So we've done this process sequentially through 3 models. The first one from IBM was an RPA-based integration. It simulated UI navigation to fetch the data from our forms. It had high and variable latency, around 45 seconds per application. So these weaknesses of the model from IBM was fixed by the next model from us at Novoville. There we used direct API integration, but we ended up with the same extraction logic. So we didn't have any UI overhead. The latency became consistent. We cut it by 2/3, but still we kept flagging trivial mismatches for operator review. So that's the weakness that was uncovered in the second model. It also existed in the first model, but it was superseded by the high and variable latency problem. But now this residual weakness became evident, and it was fixed by another model from IBM, the fuzzy match autonomous correction model. There we have enhanced extraction with autonomous fuzzy match correction, and it resolves named mismatches without the need for operator review. Why is the Swarm Assistant important in this case? We have the data sets, and the data sets are increasing both in number as more models are added, and in size as the sessions become larger and larger. Currently, we have sessions of almost 600 applications from a moderate city in Greece. These data sets are residing in Min.io, as George showed us, and they needed fast and code-free exploration. So no manual data wrangling, no scripts. That's what the tool offered us, a direct conversation against the pilot's own data. That lowered the barrier for non-technical team members to interrogate the data directly. Members of our account team that support the municipalities can do this without the need for the data engineers to intervene. And we have had several real use cases. For example, data discovery. What kind of data do I have available? Are there any directories with PDF supporting files? Document retrieval. Let me see one of the PDF files in there and read the structured fields directly. Dataset level queries. Give me all the details from a particular dataset. This gives us the full session contents without any manual parsing. Or operator decision queries. How many applications have operator decisions, and what are they? Or even cross-dataset comparisons. Compare, for example, the AI and the operator processing times across all the datasets. Not even that, but the tool offers us seamless ingestion. Whenever new data is available, even mid-conversation, then we can converse, including this dataset in our queries. And let's now see some results across the different models. And you can see the performance on the graphs on the right-hand side. So let's start with the mean action duration. That's the average time an operator spends reviewing a case. And it consistently falls across the three models. The human cognitive load proxy, this is derived from the review duration relative to some ceiling. And it climbed steadily, indicating less mental strain per review, especially the jump from the Novo model to the second IBM model, the third model of the ensemble, was impressive. The trust proxy, that's the share of operator decisions that agree to the AI's recommendations. That stayed essentially flat, showing that reliance that we achieved by changing the models did not erode as automation grew. AI automation uptake, that's the share of applications resolved without any operator involvement. Again, rising from model to model, and again with a very impressive jump at the last model, where we reached almost 81%. Finally, the mean AI latency. That's the average AI processing time per application. It dropped sharply with API access in the second model. And then because of the more elaborate methodology of extracting the information, it ticked up slightly in the second IBM model. So every model upgrade we made that human side of the workflow better, not just faster. And that is the important result we obtained. And we used the suite as the driving factor behind these progressive improvements of our models. Focusing especially in the last model we used, the IBM 2 model, we have extraction quality that drives operator experience more than raw AI speed. So AI latency rose slightly versus the previous model, yet the operator side metrics were the best by far across the board. So 1810 automation uptake, these applications that are fully autonomous, no operator needed. The AI latency rose slightly versus the previous model due to the richer fuzzy match extraction, but the operator metrics were the best yet. Lowest duration, highest cognitive load proxy. Moving to the Swarm Assistant and what it actually delivered, we have this seamless integration. We have the no-code manual join, and you can see in the example on the right-hand side, a particularly tough query about a cross-session, the AI versus operator processing time compared across all three datasets in one conversation ask. These two tools have a combined impact. The benchmarking suite allowed us to have the rigorous, citable evidence that we used in manuscripts, in deliverables, in our KPI tables throughout the project. The assistant allowed us to have the final internal sense check between the formal evaluation rounds. Together, the two provide us the rigorous evidence and fast exploration of the same data, reinforcing the same conclusion that IBM 2 outperforms its predecessors. And what have we achieved at the end of the day? While we targeted a manual processing time that is less than half the initial one, we ended up with just 13% of the initial one. And while we targeted a full-time equivalent for the validation step to be less than 30% of what we had without any AI model, we are less than 5% now. So both tools' evidence converges in the same conclusion in this set of 566 applications. And that's all from my side. I'm happy to take any questions on the pilot results or on the usage we applied either tool.
Great. Thank you. Thank you very much, Aristoteles. Gonzalo or George, from your side, is there any additional comments following Aristoteles' presentation that you would like to briefly mention before we get to the Q&A/close of the session?
From my side, I think we can go to Q&A. I don't know if George has anything to add.
No, I don't have something to add except that we showcase with Novoville and Aristoteles that the tools that we build on this project are usable to real use cases, and it's very important to wrap them up with at the moment with Unparallel in one common let's say toolbox to use from anyone who want to have these results and this exploration of their use cases.
All right. Yeah, for replicability or for other use cases as well. Yeah, it should all be together in one toolbox. Okay.